Hello friend, today I discuss about IIT entrance exam in India. IIT, JEE Mains and JEE Advanced. Okay, this is science toppers from Delhi and Noida. आज हम लोग डिस्कस करेंगे एससी वर्मा फिजिक्स जो है उनका सॉल्यूशन कि किस तरह से उसका सॉल्यूशन किया जाएगा बहुत आसानी से। टॉपिक है हमारा इलेक्ट्रिक फील्ड एंड पोटेंशियल। माई सेल्फ मिस्टर रणधीर सिंह। ओके, तो हम लोग स्टार्ट करते हैं। फर्स्ट क्वेश्चन, फाइंड द डायमेंशन फॉर्मूला ऑफ एप्सिलॉन नॉट। फाइंड द डायमेंशनल फॉर्मूला ऑफ एप्सिलॉन नॉट। एप्सिलॉन नॉट according to Ohm's law, F equal to K Q1 Q2 upon R square. Here K is equal to 1 upon 4 pi epsilon naught epsilon R. That is epsilon naught. Epsilon naught, that is the constant value for a medium. The value of the epsilon naught is equal to 8.85 into 10 to the power minus 12. Now it's unit. So चूंकि force equal to 1 upon 4 pi epsilon naught epsilon r into q1 q2 upon r square. So epsilon naught is equal to 1 upon 4 pi force into q1 q2 upon r square. If clear, so and if er equal to 1, dielectric constant, relative permittivity, so epsilon naught equal to Coulomb's square upon force into meter square. Force into meter square. So now the right dimension formula for the epsilon naught, that is note that Coulomb entered in the terms of the meter square to meter, force also, and force equal to mass into acceleration, and mass the dimensional form, and acceleration the dv by dt, velocity upon time, or v by t, or velocity length upon time. So mass into length upon time square, length upon time square, so that Coulomb's square upon mass into length upon time square into meter L square also. Clear? So, and Coulomb's here we write down, okay, I equal to Coulombs per time, charge per time, Q upon T. So Coulombs per time. So Coulombs equal to I into time. So here to put the value of I into time square and t to the power square, so that 4 and L minus 3, L that is minus 3. So write the Frisch equation. Write the Frisch equation for epsilon naught. So now direct form of the, so epsilon naught is equal to Coulomb's square upon force into meter square, so that Coulomb's square, that means amperes clear, I square into t square upon force, mass into L to the power minus 2 into t to the power minus 2 into m L square, so that I square to the power 4 m minus 1 and L minus 3. The dimension formula of epsilon naught. The dimensional formula of epsilon naught. Clear? So it is the dimensional formula of the epsilon naught. So answer, put the answer epsilon naught is equal to I square t to the power 4 m to the power minus 1 L to the power minus 3, the dimensional formula of epsilon naught. Clear? Second question. A charge of 1.0, that is not I naught, 1.0 coulombs. A charge of 1.0 coulombs is placed at the top of your college building, and another equal charge at the top of your house, means top of your house. Take the separation between two charges to be 2.0 kilometer. 2.0 kilometer. Find the force exerted by the charge on each other. How many times your weight is this force? Clear? So means here, according to question, we find the force exerted by the charge on each other. So apply Coulomb's law. Coulomb's law give a theory with respect to charge, and with respect to charge, let two charge at the top of your college building and top of your house, Q1 and Q2, the top of the house and the top of the college building. Clear? And the place the value of charge 1.0 coulombs or 1.0 coulombs means the total both charge are equal. Q1 is equal to Q2. Let Q equal to 1.0 coulomb. Clear? Take the separation between two charges to be 2.0 kilometer. That means the height, the distance between two top of the college building and the top of your house, 2.0 kilometer. Clear? 2.0 kilometer. So now find the force. The force is equal to K Q1 Q2 upon R square according to Coulomb's law. That means 9 into 10 to the power 9 into 1.0 into 1.0 upon 2 into 10 to the power 3. 1 kilometer equal to 10 to the power 3 meter. So 2 kilometer equal to 2 into 10 to the power minus 3 square. So that the value of this theory is a 2.25 into 10 to the power 3 meter. 2.25 into 10 to the power 3 newtons. So clear, the force exerted is 2.25 into 10 to the power 3 newton. So now find another link up question. How many times of your weight is this force? How many times of your weight? So now total force is equal to 2.25 into 10 to the power 3 newton. Okay. So तो चुके since weight of my body is 70 kg. So weight of the body equal to m into g. So 70 into 10 means 700 kg. 700 kg my weight. So now, and the force exerted between charge, weight of body upon force between charge equal to 2.25 into 10 to the power 3 upon 700 newtons. That answer, force between charge of the body. क्लियर? इसमें कुछ करना नहीं है, आप खुद का अपने बॉडी से आप कर सकते हैं, है ना. अगेन Recorrect the question. 1.0 Coulomb. At what the separation should two equal charge? Solution. And what the separation should two equal charge 1.0 coulombs each be placed so that the force between them equal the weight of 50 kg person. Two equal charge 1 kilo. Let Q1 is equal to Q2 equal to Q. Place so that force between them equal and the weight of 50 kg person. And force. So force is equal to M into G. So 50 into 9.8, 490 Newton force of the person, and force equal to 9 into 10 to power 9 into Q square upon R square, so that 9 into 10 to power 9 into 1 square upon the distance R square is equal to 490, so that R square equal to, find distance, R square is equal to 9 into 10 to power 9 upon 490, that is 18.36 into 10 to power 6. So R is equal to 4.29 into 10 to power 3 meter, that is answer. So we discussed 3 questions. Clear? Next, the two equal charge placed at a separation of 1.0 meter. So again 1.0 meter. What should be the magnitude of the charge so that the force between them equal and weight of 50 kg per person? Again, if the charge placed Q1 and Q2 between distance 1 meter A and B, माना कि दो चार्ज प्लेस किया गया है A और B के डिस्टेंस में, जिसका डिस्टेंस है 1 मीटर, एंड 50 kg का एक पर्सन जो है 50 kg का पर्सन, तो इक्वल चार्ज प्लेस एट सेपरेशन ऑफ, व्हाट शुड बी द मैग्नीट्यूड ऑफ चार्ज? अच्छा, चार्ज का मैग्नीट्यूड क्या होगा? है, फोर्स इक्वली लग रहा है सेम, और पर्सन का जो वेट है वो कितना है 50 kg. तो टोटल वेट हम लोग फाइंड कर लेते हैं. वेट ऑफ पर्सन इक्वल टू m इंटू जी, मास इंटू कांस्टेंट 50 इंटू 9.8, that is 490 Newton. And force, if we find force, then we find also charge magnitude. Force equal to 9 into 10 to power 9 into coulombs square upon separation 1 meter square, that is 1 meter square. So Q square is equal to 490 upon 9 into 10 to power 9. Clear? So that Q equal to under root, we solve 490 upon 9 into 10 to power 9, so equal 2.3 into 10 to the power minus 4, 2.3 into 10 to the power minus 4 coulombs answer. तब कुछ नहीं है, क्वेश्चन कुछ नहीं था, क्वेश्चन ये बोल रहा है कि दो चार्ज को प्लेस कर दिया गया, उस चार्ज का वैल्यू फाइंड कीजिए, और यदि जो हम लोग फोर्स जो लगा रहा है जो पर्सन, उसका वैल्यू, उसका फोर्स है 50 kg, तो सीधी सी बात। नाउ नेक्स्ट क्वेश्चन, फिफ्थ क्वेश्चन, फाइंड द इलेक्ट्रिक फोर्स बिटवीन टू प्रोटॉन separated by a distance of 1 Fermi. 1 Fermi equal to 10 to the power minus 16 meter, 10 to the power minus 15 meter. थोड़ा सा चेंज कर लो, minus 15 meter. The proton of nucleus remains at a separation of this order. Find the electric force between two proton. Clear? तो charge, two protons separated by distance. Proton first, proton second. That means separated by a distance, that is 1 Fermi. कहने का मतलब है 10 to the power minus 15 meter. Clear? So now find 10 to the power minus 15 meter. Now we find force. So force equal to 9 into 10 to the power 9, apply Coulomb's law, into proton charge 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19 upon 10 to the power minus 15 square. Force is equal to 9 into 2.56 into 10, that means 230.4 newtons. Clear? So answer of this question, force equal to 9 in 230.4 न्यूटन। बहुत ही आसान क्वेश्चन था ये। फिफ्थ, नाउ सिक्स्थ। फर्स्ट read question carefully. Question number 6. Two charge 2.0 into 10 power minus 6 coulomb and 1.0 and 1.0 2.0 into 10 to the power minus 6 coulomb and 10 to the power minus 6 coulomb are placed at separation of 10 centimeter. Clear? So now, where should the third charge be placed such that it experience no net force due to this charge? No net force due to this charge. क्लियर है? क्वेश्चन बोल रहा है कि दो चार्ज है, एक डिस्टेंस पे प्लेस कर दिया गया 10 सेंटीमीटर पे। अब ऐसा कौन सा पॉइंट होगा जहां तीसरा चार्ज यदि किया जाए तो वहां उस चार्ज के कारण वहां कोई भी फोर्स नहीं। तो सीधी सी बात है कि हम लोग एक मायने में ये तो बोल सकते हैं कि उस चार्ज को हम लोग यदि उस फील्ड के बाहर यदि शिफ्ट कर दिया जाए तो हमारा नेट फोर्स 0 हो जाएगा। देखते हैं हम लोग फाइंड करके। तो टू चार्ज सॉल्यूशन, Q1 equal to 2.0 into 10 to the power minus 6 coulombs, and Q2 1.0 into 10 to the power minus 6 coulombs. Clear? Two charge and separated between. Let draw a diagram for charge Q1 and separated between distance 10 centimeter or 1 into 10 to the power minus 2, 10 centimeter minus 2 meter, that means 0.1 meter. Clear? 0.1 meter. Two charge. And where should be third charge be placed such that it experience no net force due to this charge? इस चार्ज के कारण कोई भी नेट फोर्स वहां नहीं होना चाहिए। तो 10 सेंटीमीटर हमारा, अब एक चार्ज प्लेस करना है जहां नेट फोर्स 0 हो जाए। तो ये हम लोग फाइंड करते हैं, इफ चार्ज प्लेस्ड बिटवीन टू charge placed between two charge, that is third charge. So when charge placed between two charge, the net force due to this charge is equal to 0, because so that the distance between total 10 centimeter and the distance between here and distance between this part. So if the distance between this part, let it is the x meter, so it is the 10 minus x, so 0.1 minus x meter. So we have now two distance, so two force F1 equal to 9 into 10 to the power 9 or K Q1 Q2 upon R square, Q1 Q3 upon R square, and F2 two force K Q1 Q3 Q2 upon R square. That is two charge. So that if the net force is equal to 0, so F1 equal to F2. So K Q1 Q2 upon R square is equal to, sorry, K Q3 Q2 upon R square. It is the R square, that means K Q1 Q3 upon X square, K Q1 Q3 Q2 upon (0.1 minus X). So that now find the value of X. K Q1 Q3 upon x square equal to k Q1 Q2 Q3 upon 0.1 minus x square, so that 2 into 0.1 minus x square equal to x square, or x is equal to 5.86 centimeter. That is the answer. Clear? So now we discuss about next 7th question, next lecture. Thank you for today.